Hello. In this first part, we will start discussing the basics of logic. But what is logic? It is a form of correct reasoning which enables us to make sense of our experiences, of giving meaning to what we perceive, and to conclude from known data what might happen. Logic is therefore essential in mathematics and science, but evidently also in everyday life. Logic is mainly a mixture of two types of reasoning: deduction and induction. This first part will be devoted to deduction. It consists of drawing consequences. In other words, arriving at particular cases from a general principle or proposition. Let us consider some examples. John is effectively known to be younger than Mary. We can therefore conclude that Mary is older than John, and this with absolute certainty. If there was any doubt about the relative age of John and Mary, we would have said if John is younger than Mary, then Mary is older than John. Take Peter, for example. He is known not to be younger than Mary. But we can still say, and it would remain correct, that if Peter was younger than Mary, then Mary would be older than Peter. So the conditional proposition remains correct. Or more generally, if person A is younger than person B, then person B is older than person A. This conditional proposition can be applied each time we know that someone is younger than somebody else. But it cannot be applied to Peter. And this is where a first mistake is easily made. We might want to apply it to Peter, for example, based on appearances, but appearances can be misleading. So basically, the first mistake would be to confuse the conditional proposition applied to Peter and Mary with the two sentences, Peter is younger than Mary, therefore Mary is older than Peter. The if is extremely important. Another example, if the universe is small enough so that any movement within it can be detected with the naked eye, then the stars are stationary relative to one another, except at most for a very small handful. This statement is correct, but the conclusion would be correct if the premise, that is, the condition, was correct. But we know that the universe is immense. Aristotle had based his thesis of geocentrism, that is, of an immobile earth around which everything revolved, all the heavens, on the assumption that the universe was sufficiently small. An assumption is always a premise of the conclusion. Deduction, therefore, consists in concluding that if a proposition A is true, then a proposition B is true. We say that A implies B, and we write. In other words, for B to be true, it is sufficient for A to be true. That means if A is true, then B automatically is true. It comes to the same as saying that for A to be true, it is necessary for B to be true. In other words, if B is false, then A is false. Since the premise is more general than the deduction that can be drawn from it, it is easier to try to refute a particular deduction than to refute the premise, as in the case of geocentrism. It was when, in 1838, Friedrich Wilhelm Bessel detected the movement of a star relative to the others thanks to observations with a telescope that was far more sophisticated than any so far, that we could conclude that the universe was not small. This star is since then known as 61 Cygni. To say that A implies B comes to the same as saying that if B is false, then A is false. In other words, that non-B, the opposite of B, implies the opposite of A, and we write for non-B. Hence, non-B implies non-A when A implies B. And conversely, since the opposite of the opposite is the initial statement, that is, non-A is the same as A. So, non-B implies non-A and A implies B are equivalent statements. Having said that, it is too often forgotten that these equivalences are based on an assumption, the assumption of the principle of the excluded middle. According to this principle, either a statement is true or its opposite is true, and neither can be true at the same time. However, such a principle cannot be supported by empirical data, since such data cannot cover every possible case. In fact, there might be some data supporting a statement and some other data supporting its opposite. In other words, neither a statement nor its opposite may be totally contradicting one another. In fact, the closer we come to the human sphere, the less this principle of the excluded middle can be applied. Indeed, the statements, if someone is not nice, then he is mean, or its opposite, if someone is nice, then he is not mean, are both unfounded. This is also the case in the subatomic world, since quantum mechanics tells us that everything is both wave and particle. In other words, everything is both diffuse and located in a precise place. Yet modern mathematics regularly uses a method of proof based on the principle of the excluded middle. This method is known as reduction ad absurdum. It consists in proving that a statement is true by showing that its opposite leads to an absurdity. This does not invalidate mathematics, because we can always choose the rules on which to base a system of thought as long as these rules are compatible mutually. But it raises questions on the extent of the validity of its applications to studies of the sense-perceptible world. This is why in ancient India, this method of proof was avoided as much as possible. What was preferred was recursion, which makes it possible to describe or generate an infinite category starting from a small number of objects and by repeating the same rules over and over again. In other words, it enables us to generate complexity from a very simple base. The excluded middle is nothing but two-variable logic where a statement is either true or false, but never both at the same time. In ancient India, Jain thinkers had developed a seven-variable logic, and their Buddhist counterparts had developed a four-variable logic, where a statement is true or false, or true and false, or neither true nor false. Modern logicians have developed multi-variable logic. But regardless of the logic system used, some errors are common. We have already seen that we can be tempted to assume that the premise of a conditional statement is true without sufficiently checking its validity. Another common mistake is in the deduction process itself, even when the premise is true. This mistake confuses opinions with objective statements. Let us look at some examples. If so-and-so is not elected, then he is not reliable. Yet many people are candidates to elections, are never elected, but are considered far more reliable than those that are. Isn't that the case? The opposite is also questionable. If someone is elected, then he is reliable. In 1933, Hitler was elected according to the electoral laws of the Weimar Republic. Yet, can we say that Hitler was reliable? Let us consider a second example. If someone is in jail, then he has done something wrong. This assumes that all laws are just. Like Gandhi breaking a law that we consider unjust because it is against the dictates of our conscience can lead to being jailed. The opposite is also false. Many people who have done harm to others are never jailed. Let us look at another example. If science says so, then it must be true. No, science never claims to hold any truth because it is based on reasoning and observations. At any given moment, we can only know a finite number of things in a world of infinite data, and we can only know them through perception and thinking. And therefore, we might later realize that we were mistaken. The opposite is also false. It's not because science has not so far been able to determine whether something is true that it is therefore necessarily wrong. For example, if science has not managed to corroborate the existence of infectious microorganisms, then these microorganisms do not exist. This implication is incorrect. It may be that science will be able to give us some strong reason for their existence tomorrow. Or it may be that the corroboration of their existence is scientifically impossible. The question lies elsewhere. Can we base a policy on conclusions about which there is a great deal of doubt, or which are not based on sufficient empirical data? Or more generally, to what extent can a policy be based on scientific conclusions, given that these conclusions are at best transitory? Should we not recognize that politics is a matter of opinion and not try to lend them objectivity by a science which is far from being objective? A particular case of this error in the deduction process consists in confusing A implies B and B implies A, but they are not at all the same thing. For example, if the shop is closed, then I cannot go and do my shopping there. This is perfectly plausible. However, the opposite is not. If I cannot go and do my shopping there, then the shop is closed. It might be that I'm simply too busy to go shopping. We will consider less trivial examples in the second part, and they will lead us to the question of induction. Thank you.